In this video, we're going to walk through how to use Desmos to find various areas and values related to normal distribution probabilities. So I'm going to use this question here that has several parts to walk through the various types of questions that you can do for a normal distribution in Desmos. So I have my Desmos graph over here, and I want to define the normal distribution that I'm going to be using. So I can either go to the pop-up template here, go to functions, scroll down to distributions and select normaldist, or you can also just type normaldist with the parentheses. Either way, it gives you exactly the same thing. Now, if I don't put any values in here inside the normaldist function, it's going to default to the standard normal. So it shows me what parameters I need. I need a mean and a standard deviation. But if I don't put anything in, it's just going to use a mean of 0 and a standard deviation of 1. But we're going to use this problem over here. So let's see what our normal distribution for this problem looks like. We have a normally distributed random variable that has a mean of 193. So that's the first value. And then I put a comma and a standard deviation sigma of 24.9. So that defines the normal distribution that I'm working with here. Notice how I can now see this red line on the graph here. That's actually my distribution graph, but I'm not really centered at a place where I can see it. So if I just click on that magnifying glass for zoom fit, it's going to take me over here to where I can see the center of my distribution. So let's look at part A. Here we're going to find some probabilities related to a randomly selected x from the distribution. The first probability we want is x less than or equal to 222. So before the Desmos update, there were a couple of ways we could do this. We could append a .cdf and then put 222 in the input of the CDF. And that's fine, that still works. We could also give our normal distribution a variable name and then use the .cdf attached to the variable name, and that still works. But I want to show you about the updated interface here. And so where you used to have a checkbox to check cumulative probability, now we have this expandable dropdown. And so we've got lots of options here. First of all, we can pick the region that we are interested in, and then the value that we're computing. Are we computing an area, which means a proportion or a probability of the area under the curve, or are we computing bounds? So we'll get to that in a few minutes when we want bounds rather than area. But in this first probability, we want a less than probability. So less than some value in our distribution means I want a left-sided part of the distribution area. I want to find the probability that x is less than or equal to 222. So for now, this just defaulted to the mean of the distribution. So I'm going to go into this probability statement. First of all, I selected left. I'm going to go into the probability statement and I'm going to put in 222. And you can see that now it's showing me that that probability is equal to 0.878. So it puts the probability area over here in the probability statement. Now, that's giving me 3 decimal places. That is what this will default to. I usually expect 4 decimal places, and with Desmos, 4 decimal places is usually safe in terms of the tolerance. So in order to see additional decimal places, all I have to do is click on the 3-digit result, and notice it shows me that result to several decimal places. Another thing I want to just mention in this little pop out, see how it has this symbol over here, and if you hover on that, it says export a snapshot to the expression list. What does that mean? Well, if I click on that, it takes that value that it's showing me up here and it puts it in the expression list. You can even do it multiple times. So now I can see to all the decimal places that Desmos provides. I think it's about 10 or 12. The area that I'm looking for. So I only need 4 decimal places. So to 4 decimal places, my probability is 0.8779. And of course, I can enter that part of the problem to make sure that I'm on the right track before I go to the next part if I want to. All right, now to do this, the next part, I need the same distribution. I'm going to duplicate this line, but I don't want to define in multiple places. So let me undo the in equals. You don't have to do this. I mean, you can keep working in the same line of the graph and just changing the values here. But remember that if you need to share the work, or if you want to preserve how you found each answer, then you need to put it in a separate line. But again, I would not repeat the defining of the distribution. I'm going to also unclick this graph so that I'm not seeing both graphs at once. So now I want the probability that x is greater than 176. So that's going to be a right-sided probability. It's a right-sided region, right? The probability that x is greater than some value is the area to the right of that x value under the distribution curve. So it's still an area, but it's a right-sided area. Now, when I change from left to right, it just kept the value here. So make sure you don't forget to change that also. Here, I want the probability that x is greater than 176. Remember, this is a continuous distribution, so greater than and greater than or equal to are the same. It doesn't matter whether I'm calling it a strict or a weak inequality. Again, I'm going to drop down the value so that I can see the result to more decimal places and then enter that as my answer. All right, I'm going to just work with a single line over here in Desmos just so it's less confusing. But again, if you need to preserve how you got each result, you should duplicate the line and keep them all in the graph. Now I want a between probability. I want the probability x is between 170 and 240. So that is the area inside two x values under the graph. So that region, we'll call that an inner region. And again, I'm computing the area. Once again, as I selected my new region, when I went from what I had previously, which was a right-sided area, to now an inner area, it's just going to convert this probability statement. So I need to change this. I want my lower bound of 170 and I want my upper bound of 240. And then I get the area of that shaded region. Again, with each one of these, we are seeing the visualization on the normal distribution. Okay, so 0.7926 is the area under the distribution graph between the x values of 170, which is right over here, and 240, which would be right about here. All right, so those were all finding areas. We found an inner area, a left area, and a right area. In part B, we're asked to find the boundaries of the middle 54% of the distribution. So here we're given the area. The area is the middle 54%, and we want to find the lower bound x and the upper bound x. What values along the x-axis will separate the middle 54%. So middle just means that it's centered about the mean. It's an area that's centered about the mean. So we're not entering x values and finding area. We're given the area and we want to find x values. It's still an inner region, so I'm going to leave inner region checked over here, but we're not computing area. Now we're computing bounds. So I'm going to switch what I'm computing to bounds. And now in the probability statement, I'm able to change the output of the probability statement. So I'm changing the probability or proportion, because that's the same thing, area. I want 54%. So I put 0.54 in for the area, and with the selection inner, and it's going to default to that area being centered about the mean. So the values it gives me here are the lower bound and the upper bound along the x-axis, so about 174.6 to 211.4, and that is centered about the mean. Remember, the mean here is 193. So the middle 54%, I'm given the values here, lies between 174.6 to 11.4, which again, I can expand those. I can see more decimal places if I need to. I can drop them into a line, a separate line in the graph if I need to. Maybe I want to use those for something later. I can give them a variable name if I need to do that. But my lower bound is 174.6, and I am just required one decimal place over here in Desmos. So I can just use the values as they appear on the normaldist interface. Okay, so we found the boundaries of a middle 54%. Now we're asked to determine the top 14% of the distribution is at least what value. So the value we want to find is the value that separates the top 14%. So the top 14% means 14% of the distribution is to the right of the value that I'm looking for. So that means the region I want is a right-sided region. Now, when I clicked right, again, this remained at 54% because that was the last question. So now it's showing me the X boundary of the top 54% of the distribution. That's not what I want. I want the boundary of the top 14% of the distribution. So I changed the area that I'm looking for to the right of my X value. I changed the area. That's the input that Desmos needs me to tell it the area to the right, and I get the X value of 219.9. Again, I only need one decimal place, but if I needed more decimal places, I could just drop that down and get more decimal places. All right, the last part asks for the 31st percentile of the distribution, the 31st percentile. So what is a percentile? What does percentile mean? A percentile means the value that separates the lower percent of the distribution, in this case 31%, from the remaining upper portion of the distribution, which in this case is 69%. So now I need the left-sided area to be 31%. Again, that just goes back to our definition of what a percentile is. The lower 31% of the distribution is the left-sided area under the curve. That includes 0.31 of the area, and the X value that is the boundary of that is 180.7. Let's go back to part C for just a minute, just to see this connection. So when we found the top 14%, we put in a right-sided area of 0.14. That gave me the top 14%. That's equivalent to a percentile that has what area to the left? Well, if I have 14% to the right, then the area that I have to the left has to be 86%. So notice on part C, where we're talking about the top 14% as a right-sided area, we could equivalently talk about that as a left-sided area of 1 minus 0.14. So we see this connection between the top 14% and the bottom 86%, or another way to say that is the 86th percentile. So C is asking for the 14% cutoff of the distribution. That's another way of asking what is the 86th percentile of the distribution. And of course, we get the same answers here because these are really asking the same thing.